And we are live. And today we are going to take up your loops 1 and loops 2. Look at problems 1 and 5. Command a radius and circumference. We want the table to look something along the lines of radius, circumference, and size. First one, we have radius of 1 with a circumference of 6.28 and a size of small. More numbers ranging from 1 to 20, and we finish off with number 20 with a size of large. And you may remember break the problem down into steps. Step 1, print the header. This item here is considered the header. So, step 1, print the header. Print. Let's confirm that that works. Whenever you're writing a program, press F5. Often, test the program. Anytime you make a change that could cause your program to break, run it. Radius table. Hey, success! I have a header that works. Second thing we gotta do, step 2, print the radii. Print 1, print 2, print 3, print 4. Do you want me to do it? Print 1 to 20. Okay, radius. I don't know if that one's going to work. 4 radius is equal to 1 to 20. Next, a radius. There we go. We've got a working program. What do you say? Let's test it. Did I forget to mention I was going to give a 10% bonus to anybody who pointed out the error back there? There's next. Okay. Print. Anybody? Nobody? Tom? Spencer? So, print the radii from 1 to 20. Does that do it? Yay, it works. Success. That gives us the header, and it gives us the first column. We now need to calculate and print the circumference. Step 3. Make sure we dim our variables. So first of all, let's calculate circumference. Circumference. Oh, oops, spelling error. This would not have been good. Circumference. There we go. Fixed. What are you talking about, Peter? Doesn't work. Prints once. Nah. Okay, next circumference. Okay, 4 circumference. 4 circumference. 1 to 20? All right. Yes, Spencer. All right. Like yay? Circumference is calculated after this print statement. Okay. I am actually going to run this because I want to show you a troubleshooting step. Okay, there we go. So we have radius. Something odd going on there. Let me try this. This should give us an infinite loop. There we go, infinite loop. I can no longer interact with the program. Notice how it's saying not responding? You are going to start experiencing those. Now that you have loops, sometimes you will create infinite loops. Infinite loops can be got out of. Anybody know how to break out of an infinite loop? How to break out of it? Nobody? On your keyboard, there is a control key, and at the top right of the keyboard, is the break key. It says pause break. So control break, break out of the loop. Now you have to stop the program with the, and that's how you get out of an infinite loop. Don't press the red X because you will lose your work. Now let's fix this up because we are on the right track. These two lines of code should be inside the loop. We don't need to have a separate loop because it should all be happening together. Step 3 happens inside the loop. We have one problem. Let's see what happens. We want things to print side by side. How do we get things to print side by side? Comma. Let's put a comma beside the radius. It worked. Step 4. If circumference is greater than or equal to 50, then print else. We do have one slight problem. It still prints on 2 lines. We would like to print on 1 line, comma. So we need to put our comma strategically right there to keep it in one place. And that should give us our table. And it works. This is the dividing line between small and large circles. Here is the entire loop. I've added extra space so that we can have comments in there, but notice how there are 4 steps to solving this problem. Print the header, print the radii, calculate and print the circumference, and determine if the circle is large or small. 4 steps. Break the problem down into smaller steps. That helps in solving the problem. And it also means that you get one thing working right before you go on to do the more complicated thing. Now let us try our hand at question 5. So this is a table of 4s. And we want the final product to look something along the lines of 10, 14, 18, 22, 26, 46, and it goes all the way up to 210. So again, this is a problem that you can approach by breaking it down into parts. Step 1. So we do need a for loop. How about we do for x is 1 to 226. Print x next x. Will this give what we want? What do we need to do? Step 4. And you want to start at 10. Ooh. But yes, if we start at 1, we don't quite have it work. But yes, Peter is right. Let's start at 10. Again, test the program. 10, 14, 18. Next thing we want to do is have the numbers printed left to right. How do we accomplish that? Semicolon? Sure. Print with a semicolon after it. Okay, seems to work. So we've now accomplished step 2. So, step 2. Step 3. Step 3, we would like to print 5 numbers per line. How do we accomplish that? Any solutions so far? I'll show you 3. How about we try printing the numbers print x? How about we try print x plus 4? X plus 8. And then we, at the end of the line, no comma, no semicolon, so it goes to the next line. Let's first try it with what we've got here and see what happens. Okay, we're kind of on the right track. 10, 14, 18, 22, 26. It makes for an interesting pattern. There is an interesting repetition, and there's a diagonal pattern. I like it. Not quite what we're looking for. So let's try Peter's suggestion of 16. 10, 14, 18, 22, 26, 26. Not quite. Step by 20. Indeed. And this is the solution that we are looking for. So this is a working solution. We can do better. So this does all of the tasks. We've got step 1, step 2, step 3, all accomplished in one program. And you'll notice this has the fewest lines of code of any of our solutions. All we need is a dim x as integer to make this program complete. 4 lines of code. But never judge a program by the number of lines of code. This may be the shortest solution, but it is not the best. Let's grab 2 other possibilities. Copy and paste. So here's another one, and let me create a third. Let's rename this one 5. I have no idea how to spell loop-de-loop. Last one is optimal. Let's copy the code that we've got. Loop-de-loop. We are going to put a loop inside a loop. So once again, we need to create this output. Print all multiples of 4 from 10 to 226. Dim x is integer. So let's go back to our initial solution of step 4. This works to print all of the numbers that we want. And remember, we modified that with Peter's solution to give us step 20. We can create a loop inside of this loop to solve this problem. We'll need another variable, dim y as integer. Step 2, print all. So we've accomplished step 2 here. Let's just confirm that it works. It works, going 10, 30, 50, 70. Now we need step 3, print 5 numbers per line. And this is where we can use a nested for next loop. For y equals 0 to 16, and we need a next y. And notice that our print x is in the middle of this. We're actually going to do print x plus y. This will give us a similar solution. Oops. 10, 11, 12. What is... Oh. Indeed, because y counts up by 1. So let's look at that again. 10, 11, 12, 13, 14, 15. It goes up by 1 each time. That was unintentional. Even I make mistakes. Yeah. So one thing that we aren't doing is print. So let's see what happens. 10, 11, 12. Yes, it seems to be doing something, not quite what we want. What we need it to do is step 4 for our addition. 10, 14, 18, 22, 26, 30. Now it is working. So here we have now the second solution that uses step 20. First we had what I like to call the brute force method. Now we have the loop within a loop. And now last I am going to show you the cleanest solution, and that's optimal. So let us once again copy. So this is the optimal solution. Print all multiples of 4 from 10 to 226. So we go back to the initial code we had. We will need another variable, but I'm not going to call it y. This will get us what we want, printing 10 to 226 going up by 4 each time. We need to have a new line started every 5 numbers. We can count. And whenever we count, we have to start with a 0. Or whatever you need to the count to start with. Every time through this loop, you are going to increase count by 1. See how we increase count by 1? We are going to have to do something with that. If count is 5, then we print. It means we go to the next line. And then we set count back to 0, end if. So this means every 5 times through, we print a new line. And it works. Success. For the final comparison, let me add one more button. Clear screen. And CLS is the command. Instead of counting to 226, I would like to count to 218. I do not want to see these last 2 numbers. How would we accomplish that? We change what the loop ends at. Let's see how that plays out. Let's change 226 to 218 for all of our programs. No, it should work. It shouldn't ruin them. So let us see how this works out. This is the brute force method, the very first one that we created. Okay, it still shows me 222 and 226. I don't want to see those. Clear screen. Loop-de-loop, the loop within a loop, also shows us 226, 222. Finally, optimal. Notice how they're not there. Optimal gets to stop at 218. That is the optimal solution, in a way. It's the most flexible of all. And there is a slight change that you could make to optimal if you wish. Instead of using an if statement, we could use modulus arithmetic. We still need count equals count plus 1, but we could do if count mod 5 equals 0, then print. That would work equally well. And we could also modify, we could also use X. So let's confirm that optimal works. Optimal, yes, it works. Notice the 2 are missing and everything gets printed. I would like to see you come up with a solution to use only one variable for this particular problem. That's the level 4 plus challenge for you. Any questions at this point? I'd like you to implement these solutions if you can, and if you can't, ask for help with them. You're certainly more than welcome to share your solutions with each other. Try not to copy off each other. Try to use them as inspiration for your own solution. All right? Let's go. Enjoy the nice, warm, quiet room.